Let's look at this problem. We need to determine the moments of inertia of this shaded area about its centroidal y prime axis. So this y prime axis is the one that is parallel to the y axis but passes through the centroid location of this shape. So as you can tell, this problem looks similar to several of the previous problems. So we are going to directly use some of the conclusions we've got. So from the previous problem, we have determined that the area moment of inertia of this shape with respect to this y-axis is 0.1524 meter to the fourth power. And also from a problem in statics video 32, we have determined the centroid location for this shape. So the centroid location is at 0.4 meter and 0. So that's it means that the y prime axis is at a 0.4 meter distance from the y-axis. And also we have determined in that previous problem that the area of this entire shape equals to 2/3, which is 0.667 meters squared. So with all that, now we can use the parallel axis theorem to determine the moment of inertia of this area about its own centroidal y prime axis. We know that Iy equals to Iy prime bar plus AD squared. So this one right here is the moment of inertia about the centroidal y prime axis. And this is the moment of inertia about another axis that is parallel to the y prime axis. And this is the total area of this shape. And this d right here is the perpendicular distance between these two parallel axes. So it's very important that you write the equation correctly, because the moment of inertia about the centroidal axis will always be the smallest among all the parallel axes. Therefore, this is what we need to solve for. Therefore, we need to rewrite the equation. So this equals to Iy minus AD squared. Iy equals to 0.1524. The area equals to 2/3 or 0.667. Now, the distance is this distance right here. And because we have determined the centroid location, this distance is simply 0.4 meter raised to the second power. So from here, we can evaluate Iy prime bar, which is 0.0457 in the unit of meter raised to the fourth power. And that is the final solution. A common mistake will be to write the equation incorrectly and try to evaluate y prime bar from this equation, which is incorrect, because this way the Iy prime bar will be larger than Iy, when the moment of inertia about the centroidal axis should always be the smallest, because again, rotating about the centroidal axis provides the least resistance.